Because I won't be able to have a formal live lesson on this topic on the 14th, I'm recording this live lesson recording to kind of go along with the practice quiz so that you're aware of the correct solutions and why they are the correct solutions. So here we go. So the first question you were given was to pick which one of these four options shows triangles that are congruent by the hypotenuse leg theorem, also known as HL. And essentially, you have to remember that in order to use that rule, you have to have two right triangles that have congruent hypotenuses and a pair of congruent legs on each one. So when I look at these circumstances here, you know, of these four options, when I look at the option 1 and 2, those are SSA setups. And although the hypotenuse leg theorem is essentially an SSA, or side-side angle, two pairs of congruent sides and a pair of congruent non-included angles. Even though that is what the hypotenuse leg theorem kind of is a situation like that, but that's the only situation where SSA is good enough. But we don't call it SSA in that respect. We call it the hypotenuse leg theorem. And that's because the hypotenuse leg theorem can ultimately be proven using the Pythagorean theorem, because of that theorem we can usually prove that another pair of sides are congruent, and therefore you would be able to use some other rules to take care of that, either side, 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 or side, angle, side, whichever the case may be. It only works for right triangles. When I look at option 3, I don't see, right triangles there. I do have, also the angles seem to be in different places, but that's okay if the angles are in different places. And I do have a pair of legs that are congruent and a pair of hypotenuses, but since I don't know if I have right angles or not in that, it looks like it, but that's not stated as such, I can't even say that those with the two slashes are hypotenuses. So I can't use hypotenuse leg theorem on that. Option 4 is really the only one where I can say that I have two hypotenuses because they're opposite the right angles. I do have the triangles do share a leg, which means they're congruent to each other. So by hypotenuse leg theorem, those two would be congruent to each other. The next question is that you're given the following information. The triangle ABC is an isosceles triangle with angle B as the vertex angle. You're told the measure of angle A is 4x plus 2. The measure of angle B is 8x. You're asked to determine the measure of the angles below. So you're basically asked to find the measurement of the three angles in this isosceles triangle. Now, as I go through this, it's a good idea. I mean, they describe the isosceles triangle to us. It's a good idea to draw it. Since B is the vertex angle, it's the angle that's made up of the two congruent sides, and of course angles A and C would be the two angles that are congruent to each other for certain in the isosceles triangle. So when I assign measurements to these things, I can say that angle A is 4x plus 2 and angle B is 8x because that's what I was given. But I can also say C's measurement is also 4x plus 2 because I know it's congruent to angle A. Furthermore, I do know that the three angles together should total 180 degrees. So if I add all three of those together, that equals 180 degrees, and that's what gives me the equation I need to solve for x and then to ultimately find the measurements of these angles. So I combine like terms to get 16x plus 4 equals 180, subtract 4 from both sides, and divide by 16 to figure out that x is 11. Now, again, oftentimes what you'll see is that they might make 11 a choice on a multiple choice item. But I mean, if you go back and look, I mean, none of the angles had a measurement of x. Two of them had 4x plus 2, another one had 8x. So when I go through and figure out the measurements of these angles, none of them are 11 degrees. I can use the formulas, plugging 11 in for x, and I can figure out that these are the measurements of the three angles. Of course, angle A and C are congruent, and they should be, and those are the measurements. The next question you were given is that you're given this following figure here, and it asks you what additional piece of information would be needed to prove triangle ABC is congruent to triangle ABD by hypotenuse leg. Now we can see we have two right triangles. I could see that CD is a straight line segment. So I would expect that angle ABC would also be a right angle. So that's, we could assume that. They also share leg AB, so it's congruent. So they do have a pair of congruent legs. So what I'm missing is the pair of congruent hypotenuses. So that's what I'm looking for here. So knowing what you need to have for a hypotenuse leg will help you figure out what is needed in this case. And that means we need to know that the two hypotenuses, namely AC and AD, are congruent. So option 4 is the correct answer. So when I go through these other options, just kind of go through them really quickly. I have the right triangles. I have the congruent legs, as I said before. So I'm looking for congruent hypotenuses. So that's what I need. And those are the hypotenuses, so that's why it's that choice. So kind of what I just said in a nutshell. For this one here, you're given a proof. You're asked to prove that angle E is congruent to angle D. Now, those angles are in two separate triangles, and anytime we see angles involved in two separate triangles that are supposed to be congruent to each other, it's probably going to be necessary to prove the triangles congruent. You can see that we do that in step 3. We do prove the triangles to be congruent to each other. So, we want to keep that in mind in order to go through the necessary steps to do this. So, the first statement, as you see, it's next to the word given up there. It's the same exact statement here. So AB is congruent to CB and angle A is congruent to angle C. That's given information. And it's a good idea to mark it because I want to get an idea, if I'm going to prove things congruent, I should get an idea as to why. Because triangle congruences I can determine through many other ways, many different patterns. If I can establish them, would determine triangle congruence. The next thing it says that angle ABE and CBD are congruent. And I can see those are the vertical angles, and therefore that's why they would be congruent by the vertical angle theorem. So I know those two angles are congruent. Now, for 3, we are stating that the triangles are congruent to each other. So it has to be, at this point, satisfying some pattern that we're used to seeing that would establish congruence. So I want to look at that pattern. I can see from the markings that I do have 2 pair of congruent angles in between the 2 triangles and 2 pair of corresponding congruent included sides. So this is an ASA, or angle side angle setup. So by the angle side angle postulate, they're congruent to each other. Now lastly, and this is the thing we were trying to prove, that angle E is congruent to angle D. Well, we see that angle E is the third angle in each one of these circumstances. And tell you with all honesty, I didn't really have to prove the triangles were congruent to each other. If I had the 3 angles, if I had 2 angles in these 2 triangles being congruent, by the third angle theorem, the remaining angles would have to be congruent too. So, that could also have been used as well, just as a side note. That's not the way this one went, and that's the one thing you always have to make sure that you are keeping track of. Make sure you follow the logic of the proof, because I will have students that will say the third angle theorem on this one, or something similar to this. And yeah, I would agree, but the fact of the matter is I'm looking at making the statement after I've proven triangles congruent. So if I'm following the logic of the proof, I would probably be stating CP, CTC, or for corresponding parts, congruent triangles are congruent. This was a longer proof because you were asked to prove that triangle BCD is an isosceles triangle given that C is the midpoint of AE and the measurements given in the figure. So C being the midpoint of AE, of course, was a given piece of information. That's pretty straightforward. And AE being congruent to EC, well, those are the segments, made up, that are part of AE that's made up when I put that midpoint in there. So, but a definition of midpoint, that's why they're congruent to each other. I can see the measurement of angle A is equal to the measurement of angle E. That's given in the figure. Okay, because that's part of the given piece of information. The measurements in the figure were a given piece of information, which means angle A is congruent to angle E. That's by the definition of congruent angles. We're also told that AB and ED equal 12 meters. That's by given information in the figure. And that means that AB is congruent to ED. And that's by the definition of congruent segments. So now we make a statement that triangle ABC is congruent to triangle EDC. We can see here that with the congruences that we've established in the prior steps, we do have this side angle side pattern, which means we have two pair of congruent sides, a pair of congruent corresponding and included angles. So by side angle side, I can state that these two triangles are congruent. This tells me that BC is congruent to DC. And that's because their corresponding sides on these congruent triangles are corresponding parts. Now we can see that BC and DC are two of the sides of triangle BCD. And because I've just proven that those two sides are congruent by the definition of an isosceles triangle, that's how I know triangle BCD is an isosceles triangle. So as you can see, you don't always need to have a theorem be the reason for the very last statement. We were able to use various theorems and so forth to establish that we had the characteristics needed to use a definition to prove something was isosceles. So keep that in mind. So here we're given that AD is parallel to CB, and that AD is congruent to CB. This is actually going to be something we're going to be proving when we get into polygons, particularly quadrilaterals, when we get to Unit 10, starting at the beginning of the second semester. So this is actually a proof that we can do, that's something we're going to see ahead of time, that we actually have enough information and knowledge to do right now. And this kind of gives you an idea that this is how geometry and proofs work. We take previously established proofs and prove new things. So if I follow again, you have all the statements here, so you just have to provide the reasons, and that's all you're asked to do. So the first statement, AD is parallel to CB, that was a given piece of information. And I'm marking it with the arrowheads up there, because those indicate that the two segments are parallel to each other. Then it says that angle BCA is congruent to angle DAC. And as you can see, when I mark it, those are alternate interior angles, and because the lines are parallel, I do know, and AC being a transversal here, I do know that those angles would be congruent by the alternate interior angle theorem. Next, we're so that AD is congruent to CB. Now, we wouldn't have, none of the previous information would let us know that. So thankfully it was a given piece of information. As you see, it's next to the word given. So anytime you get something that's like kind of out of the blue, look to make sure it's a statement that's next to the word given or not, to see if it's just a given piece of information. And if that's the case, just state given. Otherwise, if it's something that you say, well, where's this coming from? There has to be some sort of theorem or something that's going to assist with that. So Step 4, AC is congruent to CA. Well, that's the same segment, just named differently. And as you can see, the two triangles do share the segments. So by the reflexive property, it's congruent to itself. So anytime you have something that's shared, you see it here with, a shared side. You also have some triangles presented to you in various portions throughout the lessons, and even on some of the quiz and test items that you're about to see. That you may even have overlapping triangles where some angles are shared. That's when reflexive property gets used. And so for number 5, now I'm saying the triangles are congruent, so I better see like one of these patterns that we've been talking about throughout this entire unit. And as I look carefully, and because I marked them up, I could see the side angle side pattern. Again, two pairs of congruent sides and a pair of congruent included corresponding angles. So by side angle side, I can say that they're congruent. Now these last two statements are going to be what I'm going to use to hopefully prove that the other two sides are parallel. Because what we're eventually going to do with this is we're going to say, well, if we have a pair of sides that are both congruent and parallel, then this thing would be a parallelogram. And of course, having the other pair of sides being parallel would aid in doing that. So here we're saying that angle BAC and DCA are congruent to each other. Now those are the angles, and as you can see, with AC being a transversal now for CD and AB, that those would be alternate interior angles. Well, eventually. That's not the reason why they're congruent. That's because they're corresponding parts of congruent triangles being congruent. Now some students may recognize them as alternate interior angles, and that's kind of the gist of it. We want them to be alternate interior angles or some sort of angle pairing that we know should be congruent to make things parallel. So make sure that you're not like jumping the gun and saying that because they're alternate interior angles, that's why they're congruent, because we don't have the right segments being parallel yet. These are not alternate interior angles for BC and AD. They're alternate interior angles for CD and AB. That's why, but luckily these were corresponding parts in these two triangles, so that's why that they are congruent to each other, because we've just proven the triangle's congruent. And now that we do have these being alternate interior angles, and we do know that they are congruent by the converse of the alternate interior angle theorem, I can say that AB is parallel to CD. So that is the end of the solutions. If you have any further questions, please feel free to contact me or maybe perhaps your geometry teacher. But until I get to see you in a live lesson, or if you're one of my students I just talked to on the phone, I will see you around. Have a good day.